Hello and welcome to Natural Language Processing 2. So we have already covered Introduction to NLP, applications, stages of the NLP and chatbots in the previous slide. Today we will see text processing. Under text processing, we have text normalization, back of words and TF-IDF. Term frequency, inverse document frequency. These are the two terms which you should know. Text normalization is a very important step in NLP. It means we are converting our text into a standard and consistent form so that a computer or a device can understand it easily. What is a corpus or corpora for plural? Corpus refers to the different collections of text, speech data used by computers to learn a language. A corpus can have books, articles, emails, any chat reviews, or any type of voice recordings. These two definitions are important. Coming to the steps of text normalization. Suppose you want to normalize your text, bring it down to a lower level. So there are 5 to 6 steps which are to be performed. The first is sentence segmentation, followed by tokenization. Then the third is removing of your stop words, special characters and numbers. After that, we convert the text to a common case, something called stemming and lemmatization. We will see each step in detail. The first step, sentence segmentation. Well, here the whole corpus is first divided into sentence. So if your corpus has got different paragraphs, each paragraph is taken up and it is simply divided into sentence. As you can see here on the left hand side, there is a paragraph. This is the paragraph and it has got two sentences, and sentences always start after a full stop. So after a full stop, we have separated the sentences. The next step of text normalization is tokenization. Now, picking up one sentence at a time, we have simply separated the different words, also the punctuation marks. So these are the different tokens of one sentence. Note, punctuation marks are also considered as tokens. You might get question like this. You will be given a sentence and you'll have to count the number of tokens. So tokens are all the different words or punctuations or different numbers which are coming in a sentence. Please prepare yourself with the definition of token, and also you should be able to count the number of tokens in a sentence. Full stop should also be counted. The next step is removing of your stop words. Now, what are stop words? Stop words are those words which come very frequently in a sentence, but they don't add any meaningful value to the sentence. So these are all the words which actually comes in the grammar part of English, which is needed to make our sentence a proper sentence, but they don't add proper meaning. So all the different prepositions, the articles can be considered as stop words. These are the list of the stop words, and you may have more. A, and, are. These are some of the sentences. These are some of the words which we use to construct our sentence, but they are not very much helpful for our NLP. We don't try to interpret anything from these particular words. So these are your stop words. Again, you have to do with the definition of what is a stop word. The next step is the entire sentence will now be converted into a common case. It can be uppercase, it can be uppercase or lowercase. Here everything has been converted to lowercase and the default is lowercase. So converting everything. So whatever is typed is converted into a common case. The last step is either stemming or lemmatization. Now, what is the meaning of stemming and lemmatization? Stemming means we are bringing back a word to its base form or root form. For example, we have got this word as healed. We have got this word as healed, but we know the root form or the base form of this word is healed. So basically in stemming, the suffix is removed. The suffix is removed from the word and the word is brought back to its base form. Like healing becomes heal, healer becomes heal. Studies, the es is the suffix, it is removed, and studying, ing is the suffix, is the remove. Now the output of stemming is called stem. The output of stemming is called stem. So you can see here, sometimes the output of stem might not be a meaningful word. So for this purpose, we have got the next algorithm, which is called lemmatization. So in lemmatization, the word is again brought back to its base form, but here the output is always a meaningful word. The word itself, lemma, means a word which is found in the dictionary. So here your studies is now converted into a proper base form study, which actually has got a meaning. So the difference between lemmatization and stemming might be asked. Stemming is faster than lemmatization, and output of stemming might not be a correct word, but output of lemmatization is always a correct word. In both the cases, the affixes or the suffixes are removed. So difference here, caring, the ing is removed in lemmatization and it is converted to base form care, whereas caring here get converted into car. These are some of the stem and lemma words which you can go through. The next is bag of words, which is one of the algorithm of NLP. Let us quickly see what is the meaning of bag of words. So it is one of the algorithm of NLP where we are trying to extract features from our text, and these features are helpful in our machine learning algorithms. Whenever we are conducting bag of words, all the different words are extracted, and the another output which we get here is the frequency of the words, how many times each word is occurring. So how will we start the implementation of bag of words? Again, there are certain steps. The first is text normalization, which we have already seen. Just now we have seen what is text normalization, the different 5 steps. Then is we create something called dictionary. Dictionary, you know, has got all unique words. So in bag of words also we create dictionary. The third is we create something called document vectors, and the last step is creating of document vectors for all the documents. We will quickly see what is bag of words. You definitely get one question of 4 marks from bag of words. So this is the example we will see for bag of words. So we have got 3 documents. Document one is saying Aman and Anil are stressed. Document 2 is saying Aman went to a therapist. Document 3 is saying Anil went to download a health chatbot. So in the exams also you will get 3 simple sentences and you have to implement bag of words on that. So step 1, proceed like this only. Write there step 1. You are first pre-processing the step. So document 1 after pre-processing will become Aman and Anil, all converted to lowercase. You have to note that everything has been converted to lowercase here. Anil are stressed. Well, we have not reduced stressed to stress. That is, lemmatization and stemming are not being done. You will also not do this in the exams. You will just leave it at stressed because your sentences are too small. That is why we are not doing any stemming and lemma. Neither are we removing stop words. Here and are stop words, but since the sentences are too small, for the exam purpose, you will not remove these stop words. Document 2, so you will write the sentence as it is for text pre-processing, only convert them to lowercase. Aman went to a therapist, and document 3, Anil also went to download a health chatbot. So all the words, all the tokens separated by comma. So this is step 1 of bag of words. Step 2, create dictionary. Now dictionary are all the unique words which are occurring. So when you create the dictionary, all these words will be written only once. So make a clear dictionary from all the 3 documents. And also write the heading, create dictionary. Proceeding to the third step. Okay, so in step 3, we create document vector. Now, what is a document vector? So document vector is basically, in the document vector, we write how many times each words are occurring in a document. So first you have to write down all the different words of the dictionary again. This is our dictionary at the top. And if you look at document 1, this is document vector for document 1. So if you look at the document vector, it is Aman and Anil are stressed. So below Aman, we will write 1 and 1. Anil are stressed. So below these words, we will write 1 and remaining all 0 because they are not there in our first document. So this is document vector for the first document. So similarly, you have to create for second and third document. That will be shown in step 4. So this is step 4, repeating the document vector for all the documents. So Aman and Anil are stressed. Second document has got Aman went to a therapist. So below Aman, we will write 1. Below went, to, a, and therapist. Once again, I am repeating. You will not remove the stop words. And, are, to, these are all stop words, but we will not remove them because the sentences which you get to perform are very small and we do not remove them for such small sentences. Third document, Anil went to download a health chatbot. So it's Anil, we put 1, then went to download 1, a health and chatbot. So this is the complete document vector for all the 3 documents. And this is the output of bag of words. So bag of words gives us the vocabulary of the words. So these are the vocabulary and how many times they are occurring. So you have to leave your working till here or show your working till here for bag of words. Well, this is an interesting graph. As you can see, the values, if the value of any word is higher, if it is increasing, usually that word occurs quite lesser number of times. And if value of some word is low, like this part, you can see these are the different stop words whose values and which occurs also numerous times. Some definitions of term frequency. So it is the frequency of any word in a document Our document vector table actually gives us the term frequency. Next is document frequency. So this is the number of documents in which the word occurs. So a particular word, how many times it is occurring in a document, in the number of documents. This is document frequency. Something called IDF. So IDF is nothing but the inverse of document frequency. So if a document frequency is 3, your IDF will be 1 by 3. It is the inverse. We need it for some calculations of TF-IDF. This was the output of bag of words. Continuing from here, we go to our next algorithm. So the next term is document frequency. Document frequency is how many times these words are occurring in the documents. So Aman was twice and one Anil was twice, simply counting from the bag of words. What is inverse document frequency? It's just the document frequency which becomes the denominator. And how many documents did we have? We had 3 documents. So 3 becomes the numerator. So number of documents is the numerator divided by and the denominator is the document frequency for that particular word. So this is IDF. So we have found out document frequency and inverse document frequency. So after this comes the next algorithm, which is term frequency inverse document frequency, TF-IDF. In TF-IDF, we again pick up our bag of words document vector, and on each document vector we are applying a log on the inverse document frequency. So this is the formula: term frequency of the word multiplied by the log of the IDF. This calculation won't be asked in class 10th, so you can leave your working up to the previous point. This is just for your information, and log is calculated to the base 10. So this is the output of TF-IDF, where after applying log, all the numbers or the frequency of the numbers gets converted into values. So finally our words are getting converted to numbers in TF-IDF. So this is the output of TF-IDF.